YouTube. I've been wanting one of these things for a long time, and so I found one on eBay that I'm going to put together, and just got it today actually. And it's a, if you haven't already can tell, it's a Nixie Tube Clock. It's using the IN12s. Wasn't really sure what I was going to get, because the pictures on eBay really don't do this thing any justice. The board's actually really nice. It looks to be fiberglass. Actually, I don't remember the guy I got this from, but I got the tubes actually from a different person, because I'll try and find the links again to these on eBay and post them in the description. But the guy who sells this also sells the kit with the tubes. But and if I can find these tubes again, I'll link it to this, which I should be able to. If I remember right, these tubes, at least at the time, were, even with the shipping, were cheaper than getting it with the kit. This kit's a little bit different than some of the other ones in that you've got the main board here, and the second board here that actually holds the Nixies actually will stand up on edge like such. So it'll be, like that, or better to show it like this. It'd be more like that. Which at first I wasn't too keen on, because like I said, the pictures doesn't really do it any justice. But I think it's actually kind of cool. Some of the kits will come with, or you can buy a like a little a plinth, or to where the bottom's enclosed so you can't see all the electronics. But I like to be able to see the electronics in a way. I kind of like that myself. And it actually came with a schematic and a parts list, and separates the parts with what am I trying to say? There's corresponding numbers to the, let's say, capacitors, resistors, etc., so you know which ones and where to put them. But it doesn't look like it came with jumpers, so the jumpers will have to be made, which is not a big deal. And a little tiny neon bulbs here for the decimals, or the colon. I think that's it. So it's I don't know if that's gonna show up or not, but it's a Atmel IC, and I can't remember what that Russian chip is called, but it's called something, and of course your 5.5 and little battery stuff. And when I first opened this up, I was actually a little confused with the board that holds the tubes. And I thought, actually, because some of the tubes there'll be like, say, for instance, like an IN14, like, I don't know if it's IN14A and B, but one of them has the pins like this that go into a socket, and the other ones have these really long leads that you just solder in and then cut off like any normal lead. And when I first opened it up, you know, these won't even go in the holes, and so I was a little confused at first, and then I realized that there's a little tiny bag of these little sockets that you instead of putting a you know, back in the day they had these plastic socket bases that you would solder that base to the board, and then this would just press right in. But instead they're using, I don't know, they're using these little pins, which are fine. And basically what you do is just, you know, place them on the pins like that. You just put them all the way around, and then you put that in the hole and solder that in. I don't know if that's coming through or not. Can't quite see. So yeah, that's what those are for. So yeah, I can't wait to get this started and finished. Figure out what I want to do first. Daughter board or the main board. Went ahead and put some brass standoffs. It didn't come with it, so, but I wanted to, after I started getting some of these components on here, it's not going to sit flat anyway, so you know, even if it's temporary, you might want to put it on some standoffs of some sort, plastic or brass. I'm going to take a second before I actually start soldering everything together. A couple things just in case some people are completely new to this. But if you look on the boards, they've got pictograms on them. So if you're a little confused if as far as polarity, just give you kind of a for instance. Hopefully that'll. You notice the gray band, and then if you look on the board here, see if I can get a close up. D2, it's got a little band, whereas D1 has a triangle and a little minus, but it also has a band on one side. So that's how you determine. That's the negative with the two diodes. And if you look at the capacitors, there's 3 electrolytic capacitors. They're polarity sensitive. The other capacitors are not, and they've taken the time to put a plus on the positive side, plus the negative side has a solid bar. And if you look at the capacitors, maybe there it goes, they'll have a band on it with a minus, so that's obviously negative. Not all of them do it, but some of capacitors will have a shorter negative lead. But so the short lead or the bar side goes obviously with the bar side on that, or the negative side. There's no plus on that, you know, there's a plus there. So same thing with the little diodes. One day, if you look at the diodes, I don't know if that's going to come in or not, but there is a flat side. That flat side usually is on the side with the shorter lead. That's the negative. The long lead's the positive. And you know, inside the or not inside, but underneath the Nixie tubes. That's where that goes. And they have a they have the shape. In other words, they have a flat side. Plus, they also, you know, put a plus on the positive side. A lot of times they don't put the plus on there, so that's a benefit. They've gone out of their way to make this fairly as straightforward as possible. These boards, everything is numbered. So, you know, if you look on your sheet, you know, like say that the capacitor C6 is right here, and it tells you what value it is, 470 microfarad to 25 volts. So if you pay attention, you know, you can definitely do this right with not too many problems. Back to polarity. Some of these little ICs and transistors that are like half round, you know, you want to follow the pictogram, because it shows you know, which way to put them. You see there's a half, so you want to make sure you put them the right way according to the pictogram. So right here's another one up here. So what else we got here? We got that transistor. You want to make sure that when you solder it into the to its place, the board that holds the actual tubes, it actually, what you really want to do is go ahead and use the little screw and nut there, and actually put some compound on it. Or you may not want to put compound in it at first, but you eventually, when you get it all together, you want to put compound on there, a heat transfer compound. But you want to bolt it to this first, and then use your sockets and everything, and just get it lined up, and then solder it in here. You know what I mean? That way, when you do the final assembly, it's right, the right height up and down. Because if you just go ahead and solder it in there, I haven't actually checked it, but you know, the depth might be off some. Yeah, it's just a little bit off. So you gotta make sure that, you know, you got the depth right, or you'll have to take it out. So the best way to do that is to solder in your headers into this board first, as such. There's actually another small set that goes right here, and then that sets the depth of the board here. And if you have this secured to the board like it's supposed to, then that sets the depth of the transistor here, and then you can solder it. And then you can either, depending on how you put it together, you can either just unbolt it and pull this out, or you can just solder it all in there if you've already put all the components in, which probably what I'm going to do is this will probably be left to last when I finally get this in there, and I'll do everything else first, and that way it'll be easy to set. And one more thing here. I know some people already know this, and this is boring for some people. Just fast forward. The ICs, you're going to put the sockets in first, these things, and then these things will just slide right into the socket, so you can, if something happens, you can replace this. But these socket are the ICs here, you can see that they have a little like a little notch. I think you can see that. Yeah, you can see that, I think. And then there's a notch right there, a notch right there, and a notch on this side. Hopefully you can see that. Yeah, and even this one even has a dot for pin number 1. So you want to make sure you follow the pictogram and use the notch on the pictogram and put the IC in the same position, same direction. I think that covers everything as far as polarity. And of course the battery, you know, you just follow the pictogram. It fits in there perfectly. I'm not sure if I said it or not, but the resistors don't have a polarity. The ceramic capacitors don't have a polarity, so they can go in either direction. The little crystal doesn't have a polarity. And if you look at the pictogram on the crystal, you know, you solder it in standing up and then you bend it over as such. Like I said, just about, you know, as far as polarity, everything seems to be marked. If it doesn't have a mark, it's you know, you don't have to worry about it. As far as I can tell, you know, I'm not really all that familiar with neon tubes and stuff, but I thought there was a polarity. But as far as I can tell on the board and when I was looking on the internet last night, you know, depending on the side that you hook it up, there's two little like metal bars in there. One side will light up or the other side, but if it's AC, both of them light up, so they shouldn't have any polarity. And as far as, like, you know, the little potentiometer, I mean, it's three-legged, so it only goes in one way, so you can't mess that up. Same thing with the switches, they can only go in one way. Same thing with the barrel connection, so everything else is pretty straightforward. And like I said too, you know, each resistor is like R4, R5, R6, R7, or capacitor C8, you know, or C10, you know, transistor 10 or 11 or 5 or whatever. They, you know, if you look at the corresponding numbers on the sheet, it'll tell you if you're not sure, it'll tell you exactly which, you know, transistor or resistor value or capacitor value or whatnot goes in those places. So don't get discouraged. Oh yeah, one more thing I forgot to mention. These, let's see, actually, if I can move that in frame, both of these in frame. Yeah, well, not really. Okay, you'll notice on this, the daughter board, basically, there's two just white bars. And then if you look on the main board, there's a white bar there, white bar there, white bar there. Those are just, you would just use a piece of, well, maybe, yeah, a little jumper. That's what that's for. Just a little piece of solid, preferably tinned, solid. I want to say this is, what gauge is this? Is this? I think it's 20. Nope, it is 22 gauge. Yeah, 22 gauge seems to fit pretty good. By the way, this is actually out of a little jumper kit. I'm actually going to get me some spools of this to make, you know, for like on the breadboards and stuff too. It's just I find it a little bit cleaner than the spaghetti. You know, like I really like these because it's, you know, it's there's not so much excess wire to get in the way. But that's what those little bars are. I don't know if yeah, it even says on the thing, jumpers, and that's what they're talking about. Jumper wires, just a little piece of wire.